So you've corrected your, or taken a look at your problem set from lesson 1, and you've looked at your solutions. I know those are a little bit complicated, but it's just to get you in the habit of looking at the little pieces of each of the sentences and trying to string what you know together. So if you were a little bit frustrated or unclear about how to put those together, we will clear those up next week. But for now, we can move on to lesson 2. These ones are a little bit less complicated, so hopefully you can work through some of these problems without too much hassle. So again, we're moving into working with expressions, which is a little bit different from equations, but putting mathematical sentences together using written out sentences. Okay, so for your exercises, you're going to be writing out expressions. Alright, so just as a little quick thing here, an expression is a mathematical sentence, so a math sentence, that doesn't contain an equal sign. Of course, this is different from an equation, which is a math sentence that contains an equal sign, which is what you were doing last lesson. Alright, so I'm just going to do a couple of the exercises with you, or while you're taking notes. I'll probably do the first 3, and then I'll go over what it means to be linear or nonlinear, because that's part of our instructions here. Alright, so we need to write out our expressions and determine whether or not they are linear or nonlinear. Okay, so again, just for some practice, we know that sum means that there's going to be some addition in our math sentence. We know that there's a number involved. Okay, and that we know that there is 4 times in there. So we know there's 4 times something in there. Okay, and we see again this phrasing, the number. So again, when we don't have an exact number, that's our variable. That's going to be our placeholder. So we can call our number x. Alright, and we know that we're going to be multiplying it by 4, because that's what 4 times the number means. So our little portion of this expression is going to be 4x. 4x, not 4 times, or 4x, which means 4 times x. Okay, so that's just a little thing here. Alright, so I have a number, the sum of a number, and 4 times the number. So I know that 4 times the number is going to be 4x, and that the number is itself is x. So therefore, my expression, my resulting expression, is going to be x plus 4x. Okay. Number 2, we have the product of 5 and a number. Product of 5 and a number. Again, we don't know our number, so we can call the number a placeholder or a variable called x. Alright, so product means multiplication, so we have 5x. Alright. And we have multiply 6 and the reciprocal of the quotient of a number, and 7. So remember that reciprocal means that it's a number that is going to be changed into a fraction under 1. Alright, so if x is our number, then the reciprocal would be 1 over x, just flipped, right? So multiply 6 and the reciprocal of a quotient of a number and 7. So reciprocal just means, again, a fraction or a flipped number if it were a fraction over 1. So then we know that we also have to multiply 6, so times 6. And the quotient, so quotient means the answer to a division problem. So of a number and 7. So a number is, again, our placeholder, which we're going to call x. And if we have the quotient, it's divided by 7. So if we want to rewrite this as a fraction, it would be x divided by 7. So they're telling us to take the reciprocal of x over 7. So then it would be 7 over x, because reciprocal means that you're flipping it. So you're taking this quotient, or multiplying it by 6. Okay, so multiply by 6. Alright, so yeah, so I'm going to box my answers here because that's what we're working with. Alright, and I'm going to go ahead and add a page because I want to have enough space to be able to explain linear versus nonlinear. Okay, so let me change up my colors here. So how to determine linear versus non-linear expressions. Okay, so eventually we're going to be taking these math sentences and turning them into graphs. Okay, so our math sentences, whether they be expressions or equations, will have to be graphed. Okay, and remember that to be able to graph something, we need we need ordered pairs. That have an x portion and a y portion to them. Okay, and you should have graphed something before, or where you have a table of x and y values, right? So just to kind of give you a simplified version of this, let's take our first expression, which is x plus 4x. So if our expression is x plus 4x, you should be able to find what our output value is, or our y value, if I have a number of x values. Okay, so what I mean by that is if I were just to plug in, say, 1, 2, and 3, right, in our expression, I would write that as 1 plus 4 times 1, 2 plus 4 times 2, and 3 plus 4 times 3. Okay, so if I were to calculate these out, I would get 1 plus 4 times 1 is 5. 2 plus 4 times 2 is 10. And 3 plus 4 times 3 is 15. So then my output values, or my y values, would be 5, 10, and 15. Okay, so just taking a look at this, I see that every x value has only one y value. Okay, if this is the case, then I have a linear expression. Because if I were to graph this, right, I would see that the graph is a straight line. Okay, it's a straight line. If I were to put these on a coordinate plane, I would see that my graph is a straight line. Okay, so that's just kind of the way, just kind of a simple way to see if there are, see if something is linear or nonlinear. Try to work out some x, or try to put in, write out a table where you have, just pick a few x values and see how many y values there are for each one. Or vice versa. See how many how many x values there are for each y. And if you are able to come up with a line as a graph, then you have a linear expression. If you can't get that far, that's fine. Just go through and write out your different expressions. I'll try to post up some other videos where people explain better linear versus nonlinear, and then we'll just pick it up on Monday, how to tell if an expression is linear versus nonlinear. All right, so that goes the same for the problem set as well. Okay, so just work out or write out the expressions, and then we will pick up how to tell if they are linear or nonlinear. All right, have fun.